This procedure covers the development of thermal profiles for BGA component removal and replacement using the AirVac Smart Track BGA Rework system. The procedure will automatically develop an optimized profile. The minimum skill level needed to complete this procedure reliably is expert. The conformance level reached when this procedure is completed properly is high. See the web page for a list of the tools and materials required to complete this procedure. A caution about operator safety. A thorough review of the equipment manual and comprehensive training are mandatory. Daily maintenance is essential. Consult the equipment manual for more information. A caution about component sensitivity. This method may subject the component to extreme temperatures. Evaluate the component's tolerance to heat prior to using this method. Plastic BGA components are especially sensitive to moisture absorption. Carefully evaluate pre-bake requirements. A caution about circuit board sensitivity. Circuit boards are made from a great variety of materials. When subjected to high temperatures, they are susceptible to the following types of damage. 1. Layer delamination. 2. Copper delamination, separation of pads, barrels of inner layers. 3. Burns and solder mask chipping. And 4. Warp. Each circuit board must be treated individually and scrutinized carefully for its reaction to heat. If a series of circuit boards are to be reworked, the first several should be handled with extreme care until a reliable procedure is established. 1. Overview. This procedure automatically creates a thermal profile based on user-defined target parameters. These may include board temperature, soak duration, BGA package temperature, BGA package ramp rate, solder joint temperature, and time over reflow. The Smart Track profile development method is non-destructive since drilling holes to embed thermocouples is eliminated. However, profile development circuit boards may be subjected to multiple thermal cycles. The Smart Track method automatically adjusts heater temperature, gas flow rates, and duration on a real-time basis. The method uses an automatic repetition procedure, using information learned from previous runs to optimize the process. Note: read and understand all instructions that accompany each project prior to starting. Note: prior to starting the profile development process, both the BGA Rework machine and the circuit board should be at or near room temperature. Avoid the use of fans to cool the circuit board or BGA Rework machine during profile development. Doing so may interfere with the software program. Allow the circuit board and BGA Rework machine to cool naturally. Note: profiles developed on one AirVac machine are portable and may be transferred to other AirVac machines. Note: if the circuit board has multiple BGA component locations that require profiles and all the BGA components are the same type and size, one rework profile may be used for all. The BGA component location to select for the profile should be the one that will generally be the most challenging to rework. The most difficult BGA components to rework will generally be 1. Closest to the edge of the circuit board. 2. In the most densely populated area. 3. Near or surrounded by a ground plane. Note: this procedure references temperatures used when processing BGA components soldered using tin lead solders. Temperature adjustments may be required when processing components soldered using higher temperature lead-free solders. 2. Initial setup. Step 1. Select the BGA Rework nozzle that will be used to develop the BGA Rework profile. The nozzle part number should correspond to the BGA physical size. Test fit the nozzle. The nozzle should fit over the BGA component with minimal gap. Record the nozzle part number, BGA component height, and circuit board thickness on the BGA Rework process worksheet. Note: depending on the BGA nozzle type, the epoxy that secures the thermocouple to the top of the BGA component to be profiled may prevent the BGA nozzle from contacting the circuit board surface. Step 2. Test all thermocouples prior to each use using a digital thermometer. Step 3. Test fit the circuit board on the base of the BGA Rework machine. Consider the following. 1. The need to remove components or other hardware to allow the location to fit under the nozzle without interference. If components need to be removed, see the appropriate procedure. Properly label removed components so that they can be replaced. 2. The need to apply heat shields using high-temperature tape or aluminum foil. 3. The location and placement of thermocouples. Step 4. Clean the top of the BGA component to be profiled. Place the tip of thermocouple number 2 on the center of the BGA component. Apply high-temperature tape to temporarily hold the thermocouple in position. The tape should not cover the tip of the thermocouple. Step 5. Mix up a small amount of thermal adhesive. Stir for 1 minute to ensure a complete mix. Apply a small dab to secure the thermocouple tip to the BGA component top. Place the circuit board in an oven for 15 to 30 minutes at 160 to 175 degrees Fahrenheit to cure the adhesive. After the adhesive cures, remove the circuit board from the oven and allow to cool. Step 6. Place thermocouple number 3 under one corner of the BGA component. Place thermocouple number 4 under the opposite corner of the BGA component. Thermocouples should be inserted far enough so that the wire insulation is just under the BGA component. Optimum location for these thermocouples is between the second and third row of BGA solder balls. If needed, check the location of the thermocouples using a microscope. Secure the thermocouples to the circuit board surface using high-temperature tape. Note: the corners selected should be those closest to adjacent components or ground plane areas. Step 7. Place thermocouple number 5 under the corner of an adjacent component. Secure the thermocouple to the circuit board surface using high-temperature tape. Apply high-temperature tape to divert hot air from the BGA Rework nozzle from flowing directly onto the thermocouple. Step 8. Place thermocouple number 6 directly under the center of the BGA component on the opposite side of the circuit board, directly in contact with the circuit board surface. Secure this thermocouple to the circuit board surface using high-temperature tape. Three. Profile development setup. Step 1. Place the circuit board on the base of the BGA Rework machine. The circuit board should be centered over the bottom heater. Clamp the circuit board in place using the built-in machine clamps. Step 2. If needed, remove the tape previously placed on the top of the BGA component to be profiled. Step 3. Plug in the thermocouples as required. Step 4. Install the BGA Rework nozzle in the BGA Rework machine. Depending on the nozzle type, the epoxy securing the thermocouple to the top of the BGA component may prevent the nozzle from contacting the circuit board surface. Step 5. Position the circuit board so that the BGA component to be profiled is aligned below the nozzle. Fine adjust the X, Y and theta positions and lock the machine base. Step 6. Lift the board carrier and place supports under the circuit board to support the area around the BGA component to be profiled. Check to be sure the supports contact the circuit board surface, not components, then lower the board carrier. Step 7. Position the IR sensor thermocouple number 1 approximately 2 inches from the edge of the BGA component being profiled. The sensor should be above a spot on the circuit board surface free of components. The IR sensor averages the surface temperature over a 3-inch circle. Step 8. Power on the machine. Pass the operator registration and password login screens. Step 9. Select Control, Thermal Smart Track, Auto Temperature Profiling. The Thermal Smart Track screen appears. The system will automatically initialize the process parameters to the default settings. These factory settings represent a good starting point to begin the profile. If needed, the system will make adjustments automatically during the optimized cycles. Note: prior to starting the profile development process, both the BGA Rework machine and the circuit board should be at or near room temperature. Avoid the use of fans to cool the circuit board or BGA Rework machine during profile development. Doing so may interfere with the software program. Allow the circuit board and BGA Rework machine to cool naturally. Step 10. Enter the specified information listed on the web page into the system. Values may vary depending on the application. 4. Profile development operation. Step 1. Recheck the values are entered into the automatic temperature profiling screen. Step 2. In the Options section, Click the cycle start-stop icon to start the automatic temperature profiling cycle. Step 3. If the automatic temperature profiling cycle fails to start, follow the pop-up instructions. Step 4. Monitor the process and stop the system if the circuit board control thermocouple number 1 temperature exceeds 183 degrees centigrade. You can monitor various stages by observing the following indicators. Board. This stage ends when the board control target temperature is reached. Preheat. This stage ends when the circuit board target temperature of the board control is reached. Soak. This stage ends when the soak seconds value of the device joints is reached. Reflow. This stage ends when the reflow seconds value of the device joints is reached. Cool down. This stage ends when the solder joints are under 183 degrees centigrade. Step 5. If all of the thermal profile parameters have been met on the first pass, the done indicator will be illuminated. Proceed to section 5. Profile saving. Step 6. If all of the thermal profile parameters have not been met on the first pass, the optimize indicator will be illuminated. Note, the system will automatically run up to 3 additional cycles. Do not start or stop the machine, nor make any parameter changes. The system will restart another cycle once the circuit board is cooled down to the circuit board control thermocouple number 1 start temperature. The following process optimization rules may be applied during the optimize cycles. Only one rule can be applied per optimize cycle. 001. The targeted device joint average temperature was not achieved. Attempt to increase the device top maximum temperature by 5 degrees centigrade. If the device top maximum temperature is currently implemented, this rule is skipped. 002. The actual reflow time was less than the target reflow time minus 10 seconds. The system provides a 10-second success window. To compensate, the system will consider the actual cool-down time. Next, the system will compute the necessary time extension to achieve the targeted reflow seconds. This time extension is implemented using a device joint average temperature maintain mode. The heating and flow subsystems will be pulsed on and off to maintain the current device joint average temperature, rather than simply turned off when the joint temperature is reached, as in the original cycle. 003. The target device joint average temperature was not achieved. If the targeted device joint average temperature is at the minimum, this rule is skipped. Step 7. If the system changes any values, record the values on the BGA Rework process worksheet. Step 8. After the additional profile cycles, the system will illuminate the done light. Note, if an optimized cycle cannot be achieved, the system will report this condition to the user. Refer to the Air Vac manual for further information. Values may vary depending on the application. 5. Profile saving. Step 1. Save the new profile by clicking on the Save button in the upper left corner of the screen. Step 2. Enter the long name of the profile. Step 3. Click on the thumbs up icon, then OK, then click on the thumbs up icon again. Step 4. Using the print options, print a copy of the graph page and run a data point summary report. Step 5. Click on the thumbs up icon to display a new screen. Step 6. Check the build profile box. Step 7. Check the component removal box. Step 8. Check the removal retry box. Step 9. Check the component placement box. Step 10. Record the nozzle length. Click on the asterisk and select the nozzle size. Step 11. Record the device height. Click on the asterisk and select the BGA type. Step 12. Record the circuit board thickness. Enter the value. Step 13. Save the profile using the profile long name as follows. 1. Customer name. 2. Circuit board type. 3. BGA ball count and part type. 4. BGA location. 5. Nozzle part number. 6. Operator initials. Step 14. Send the file to Profile Library 199. Step 15. Click on the thumbs up icon. Step 16. Click on Save equals OK. Step 17. If needed, the new profile can be tested. It is suggested that the removal cycle be performed using this new profile. Step 18. When complete, remove all thermocouples except number 6 bottom side. Remove the circuit board from the machine and store for further use.